Yes, guys. So now proceeding with our Docker containers ahead. Okay. So today we'll be doing a bit more commands onto our Docker containers, right? So first of all, let me install container over here on this Linux machine. So once you create your Linux machines, we'll be installing Docker over here. So I'll say yum space install space Docker and then -y. So Docker installation will start it now, right? So once your Docker installation is done, okay, we will be going with starting our Docker service. Okay, so to start your Docker service, we'll be giving systemctl start Docker, right? And then enter. And for enabling your Docker service, we'll be saying systemctl enable Docker over here. We have to start and we have to enable our Docker service, right? So I'll be starting and enabling my Docker service. So once you start and enable your Docker service, so now if you check systemctl status Docker, my Docker will be up and running over here. Yes. Yeah, ఓకే యా అంటే నేమ్ ఇవ్వలేదు నేను నేమ్ ఇవ్వలేదు ఎగ్జాక్ట్ ఐపీ వచ్చేసి ఏదైనా ఒకటే నో ప్రాబ్లం ఓకే సో ఓకే అవుతుంది అది స్టార్ట్ అవుతుంది ఇప్పుడు అయింది చూడండి సేమ్ నాకు అవుతుందంటే మీకు కూడా అవ్వాలి ఓకే కానీ ఇప్పుడు అవుతుంది అంటే సిస్టమ్ రెడీగా ఉండాలి ఓకే సో చెక్ ఇట్ ఓకే బట్ స్టిల్ ఒకటి చెప్తాను ఫర్ ఎగ్జాంపుల్ ఇఫ్ యూ గాట్ okay docker images when you give and when you give enter if it shows like this your docker is running if it shows you it is not ready okay then it is not ready so docker command should start executing for us that is important idi ready aval man okay right so if you see the images right now I don't have any images with me okay and if you want to check how many containers are there you will be giving docker space ps okay and if you check over here I don't have any containers also I don't have any images I don't have any containers also so let me pull some images so for pulling the images I will give docker space full space okay so let me pull MySQL image I will give enter so MySQL image is getting downloaded from Docker Hub okay when you give docker pull command it will go to Docker Hub and it will download the image right now it is downloading the image for us so image got downloaded over here successfully now check how many images are there okay you can see that one MySQL image is there one image is there right so similarly let me download one more image I will say docker space full space okay let me download one okay Python image over here okay so I'll give enter over here and you will see that Python image is getting downloaded okay so right now how many images I'm having if you check I am having two images with me guys one is my MySQL image and the other is Python image okay so using these images I will create my containers right so to create your containers you have to run docker space run space -it hyphen name let me give my container name as c1 c1 is my container name or you can give any name like Rajesh Mohan you can give any name to your container okay I'm calling my container as c1 and I will use MySQL image and to go inside this container I will write /bin/bash okay so now if I will give enter over here you will see that within a second container will get created and I'm inside my container also okay I'm inside my container also if you give ls over here and if you check these are the files which are available in your MySQL container okay these are the files which are available in your MySQL container right because this is our MySQL container very good now let me exit from this container okay now similarly let me create one more container using Python image okay so I will say docker space run space -it hyphen name I will call this container as c2 container I will use Python image and normally you are writing /bin/bash right we are writing slash bin slash bash to go inside a container, right? Or else you can also write simple bash also. It's same. You can write slash bin slash bash, or else you can simply write bash also. It's same. Huh? Directory. Direct. Okay. So bin or bash is the same thing, guys. So in a short form, you can write bash also, and if you give enter, you will go inside a container only. Okay, so we are going inside container only, and this time we have created a Python container, and you can see these are the files which are there in Python container. So for any container, you can write bash. Okay, for any container, if you want to go inside, we can write bash over there to go inside, right? Now, so let me exit from this container. Okay, now let me check how many images are there. I have 2 images with me, right? Now let me tell you one more thing, guys, that Docker is a very smart tool, guys, actually. Okay, the way Docker works, it's a very smart tool for us, actually. So let me show you one thing over here. What I'll do is I will create one container. I will say Docker run -it -- name. I will create container 3 C3, okay, and I will use CentOS image. Do I have CentOS image with me? No, right? So I don't have CentOS image with me. So what Docker will do over here, Docker will first check locally that that image is available or not. First, it will check locally in that machine that that image is available or not. If that image is available, it will create the container. Or if it is not available, it will go to Docker Hub. It will go to Docker Hub, and then it will search for image over there. It will download the image and it will create the container. Okay, so it's a very smart tool. If it doesn't find it locally, it will go to Docker Hub, it will download the image. Okay, so then it will create our container, right? So it is not mandatory that image should be downloaded all the time. This will also work over here. It will search first locally, but then it will go to Docker Hub. Okay, and I will give bash to go inside this container. So with this, what will happen? It will search for the image locally, then it will go to Docker Hub, it will download the image, it will create the container for me, and I will go inside the container also. Okay, so now if I give enter over here, you will see that first of all, it was unable to find the image locally. So CentOS was not available locally. So then what it did? It went to for pull over here. It downloaded the image, okay, and it has created a container for me also. And right now we are inside the container, okay, and this is our CentOS container. So CentOS image was not there. It downloaded the image, it created the container, and I'm inside the container also, right? So in this way also you can create your containers. Okay, very good. Now let me exit from this container and let me show you one more thing. So total how many images are there with us? 3 images are there now. CentOS image also got downloaded, right? Now, so let me pull one more image. I will say Docker space, full space. Let me pull Java image. Okay, so I'll write Java over here, and Java image is getting downloaded. Multiple images. Okay, I'll show. You can create your own image also. Okay, right now total how many images are there? If I give Docker space images, okay, 4 images are there now, right? So let me create one more container now. I will say Docker space run space -it -name. Let me create a container C5 container, and I will use Java image, and generally we are writing /bin/bash. So in a short form we are writing bash to go inside container, or else you can write sh also to go inside a container. /bin/bash will also work, bash will also work, sh will also work. Okay, but with sh what will happen is, if you give sh and enter, you will only get a hashtag mark over here, guys. It will not show you the container id. It will not show us the container id. It will only just give us the sh mark, only the hashtag mark. Okay, so because of this reason we don't use sh mostly. We mostly use bash because bash gives us the container id also, right? So if I give ls over here and check, these are the files which are there inside my container over here, right? Very good. Now let me exit from this. Okay, and now let me check how many images are there. I have 4 images, and check how many containers are there. Okay, so now let me show you one more thing also, guys. Okay, so there is a small difference between docker ps and docker ps hyphen a. Docker ps hyphen a, it will give you all the containers, guys. The name is all over here. Okay, so docker ps hyphen a, it will show you all the containers. It will show us all the containers over here. Okay, so if I give enter over here, you will see, okay, that these are my containers over here. Okay, so now tell me, if I give docker ps, it is not showing me any containers. But when I give docker ps hyphen a for showing all the containers, it is showing me all the containers. What is the difference over here? You know, more. Okay, no, no, only one simple thing is there. Okay, only one. Docker ps will show you running containers. Docker ps will show you running containers. Docker ps hyphen a will show you running containers, even stopped containers also. So right now your containers you have created, they are in exited mode. Exited mode over here means they are in stopped mode. Okay, now what I will do, you see, docker space start space, let me start c1 and c2 for example, container 1 and container 2. I will start 2 containers now. Docker start c1 c2. Okay, now if I give enter, you will see c1 c2 both got started over here, container 1 and container 2. Now check docker ps, how many containers are running? 2 containers are running. So that's why it is showing 2 containers. But when you view docker ps hyphen a, it will show you all the containers. So this will
Sir,
show
sir,
all the containers.
sir,
Yes, yes,
sir.
yes.
Video
Yeah, yeah,
is
yeah.
stopped.
It is available now.
Yeah, yeah.
Okay, so if you give you docker ps, it will show you only the running containers. If you give docker ps hyphen a, it will show you running containers and stopped containers also. Okay, so only 2 containers are running. That is the reason you see docker ps giving you 2 containers only. And docker ps hyphen a, so they are running or not running also, it will show you here. So 2 are in exited mode, which means these 2 are not running. And these 2 containers are running since 39 seconds and 38 seconds. Okay, very good. Now let me start the other 2 containers also. I will say docker space start space C3 and C5. So to stop it, you can write docker stop. To start it, we can write docker start. Okay, simple command. So I'll give C3, C5 also got started. Now when you give docker ps, it will show that all the 4 containers are running over here. All 4 containers are running. We have created the containers and all the 4 containers are running. Right? Very good. Now guys, in yesterday's class, I told you that containers will use very less CPU and very less memory. Okay, they use very less CPU, very less memory. Let us see practically now that how less they are using. Okay, so to check your containers utilization or to check your containers CPU and memory, that how much they are using, we have a command as docker space stats, guys. If you give docker stats command, it will show you that how much CPU and memory you are utilizing over here onto your containers. Okay, so now if I give enter over here, it will show you that how much CPU and memory we are using over here. So if you check over here closely, okay, all the 4 containers are running C1, C2, C3 and C5, right? Okay, and if you check the CPU utilization, it will change, guys. For 1 second it will change. So it is just 0.01% is the CPU utilization, 0.01, and they are in running state over here. And if you see the memory utilization, C5 is just running with 412 KB only, not even MB, and C3 container is running with 4 MB. This is with 1 MB and this is with 2.87 MB. So they are in MBs only, and no container is even 10 MB also. They are not even occupying 10 MB space also. But still they are running, and they are running very, very fast. The reason they are occupying so less memory is they are not having any operating system. They will consume it from my Linux machine. And if you see the memory percentage utilization over here, okay, that it is using 0.04, not even 1%, and 0.43, this is also not even 1%. So you see, if you add more load also, it will be still be very less, guys. So this is less than the size of our normal picture. Your picture will be having around 5 to 10 MB size. Your container is running less than that amount of size over here. And my Linux machine is running with 8 GB as the storage, as the memory, and this is running with just in MBs, 2 MB, 3 MB, 4 MB. It will not even cross 10 MB also in a running state. Okay, so individually if you want to check, now it is showing for all the containers, right? Individually if you want to check, okay, you can give the command as docker space, okay, same stats command only, stat space, give your container name like C1, or you can give container ID also. You can give container name, or you can give container ID also. You can give any one of them, right? So I will give enter over here, and now you see that it is showing me the utilization of one container only, right? It is showing me the utilization of one container only over here, okay, and it is using just 2.87 MB. Okay, so I can give container name, or I can give container ID also, guys. Okay, so you can give container ID also over here. Anything is okay. So you can run docker space stat space, and we can give container ID also, like this, like this. So container name or container ID, both are unique for us, and you can use any one of them for checking their utilization, right? So Docker stats will give you the CPU and memory utilizations, guys. It's an interview question also. They will ask that how to check the CPU and memory of your containers. Okay. Now let me show you guys that how many processes your containers is using. Okay. So before that, let me show you how many processes my Linux machine is using first. Okay, so to check the processes in your Linux machine, we will give top command over here, guys. Top top. If you give top command, it will show you how many processes are running inside your Linux machine. So if you give top, you can see 111 processes are running over here, guys. It will be always near to 100, or it will be more than 100. 111 processes are running over here, guys, in your Linux machine, right? Now if you see the same thing on your containers, let me show you guys that how many processes your container is using over here. Okay, so now I will show you the processes inside your container. Okay, so to check that, we will run docker space top command, top. Okay, so again you can give your container name or container ID. For example, you want to check C5's how many processes, if it is running, you want to check, right? Docker top C5, And if you give enter over here, it will show you how many processes are running inside your C5 container. Okay, so over here you can check only one process is running inside my container, guys. Only one. In my Linux machine, 100 plus are running. It is only one, which means only 1% of your Linux machine's processes it is using. Your Linux machine is using so many processes. There is a reason behind that actually, because it is running with complete operating system. When you are running with complete operating system, behind background processes will always run. On your Windows machine also it will run, on your Linux machine also background processes will run, and it will be nearly to 100. But in containers, they are running only one process. So it is unnecessary processes will not run over here inside containers, guys. Only the process which is required, only that process will run. If I add more load also over here, it will not go beyond 3 to 4 processes. That is the reason it uses less CPU and less memory, because there is no unnecessary processes are running over here. So Docker has removed all the unnecessary things, guys. Okay. So same way you can check with container ID also. If you give Docker top and if you take any container ID also, you can check container name or container ID. Both will work over here. See, it will show you that only one PID is working over here. Okay, and it is using only one process. Right? Very good. Okay, so in terms of CPU, memory, and processes, we came to know that it is using very less. Right? Now check how many images are there. Okay, if I go for Docker space images, it is showing you number of images, right? And if I go Docker space ps, it will show number of containers, right? So every time I'm giving these two commands, Docker images, Docker ps, Docker images, Docker ps. So instead of giving these two commands one after the other, from a single command I want to know how many images are there and how many containers are there. From a single command I want to know both the things. Okay, so you can give Docker space system space df over here. So with this command it will show you that how many images and how many containers are there. Okay, both the things it will show. So if I give enter over here, you will see now that it will show me both the things over here. You can see, so total how many images are there? 4 images are there. Total how many containers are there? 4 containers are there. So one default volume is there, and there is no cache over here also. Okay, so we will talk about volumes also, okay, in some time. So you can see total 4 containers and 4 images are there. So in a single command it is showing us both the things, right? And even if you want more details, okay, so in this thing only, if you want more details, okay, you can run Docker space system space df, and you can give -v option over here. So -v option will give you even more details regarding your Docker system. Okay, it will show you how many images are there, how many containers are there, and with image name and container name also it will show you. Right? So if I give enter over here, you see, okay, so how many images are there? 4 images are there. So it is showing you image name, right? And how many containers are there? 4 containers are there, and it is showing you container names also over here, and one default volume and no cache. Okay, so these 4 images with names and these 4 containers with names and created time. So entire information it will give you over here, okay, from our Docker system command. With Docker system df, you will get the entire information. So -v is also an option over here for us, and same thing you can check with, okay, the same command you can add after df. Okay, it will also give you the same thing only. I you can add -v, or you can write --verbose, will give you the same thing. If you write -v also, it gives you the same thing, or if you write --verbose also, it will give you the same thing over here. right? Very good. Okay, so now going further. Okay, so till now we have created containers over here, guys, right? We have created containers. Very good. So now what I want to do is I want to create container along with the volume, means along with the disk. For your virtual machine also we attach disk, right? So for containers also we can attach disk. Okay, and the benefit over here is containers, multiple containers can use same disk, but multiple virtual machines cannot use same disk. You can attach, okay, disk is nothing but your hard disk only. Okay, so for your laptop or for your virtual machine, one hard disk you can attach it to one virtual machine at a time, or else you can remove and you can attach it to other virtual machine also, no problem. But in containers, at a time, simultaneously, you can use container volumes for both the containers. Okay, one more advantage. Now I will create a container along with a volume. Okay, so now, okay, so how many images I have over here? If you check over here like this, okay, so I have 4 images over here. So let me download one more image, or else I'll say Docker space full space Ubuntu over here, guys. Okay, and if you give enter over here, you will see that one Ubuntu image is getting downloaded, and it got downloaded also. Okay, so I downloaded one more image over here, and that image is Ubuntu over here, guys. I downloaded Ubuntu image, right? Very good. Now let me create container, and along with container I will create volume also. Okay, so I'll say Docker space run space -it hyphen name. I'll give a name to this container as C6 container. I will use, okay, Ubuntu image over here, right? So but before that, okay, let me add my volume option over here. So normally you are giving your image name and then you are creating your container, right? But when you want to create volume with your container, give -v option after you give your container name. So -v over here is nothing but adding volume along with the container. And let me give a name to my volume as Rajesh. Rajesh is my volume name. Okay, so Rajesh is my volume name over here, and I will use Ubuntu image to create the container. Okay, and to go inside the container, I will write bash. So same command only, I'm just adding -v option and I'm giving my volume name. That's it. It's the same command only, but I'm adding -v option for creating containers along with volume. Okay. So now if I will give enter over here, you will see that container got created. I'm inside the container also. And if you give ls over here and check, you can see Rajesh volume also got created over here. So you can see Rajesh volume over here. This is my Rajesh volume. Okay. So now what I will do is I will go inside Rajesh volume. Okay. So right now I'm inside Rajesh volume, and inside Rajesh volume there are no files actually as of now. So let me create some files inside Rajesh volume. Okay. So I'll give touch space file1, file2, file3, and file4. So I'm creating 4 files inside Rajesh volume. So inside my Rajesh volume, okay, I'm creating 4 files over here, guys. Okay, so I'll give enter over here. You can see 4 files got created, and if you press ls over here and check, okay, 4 files should be there inside Rajesh volume. So where is this Rajesh volume? Rajesh volume is attached to container 6. We have attached our Rajesh volume to our container 6. Right now Rajesh is used by container 6 only, right? Very good. Now I will exit from this container. Okay, and now what I will do is I will create a one more container, guys. I will create a one more container, and I will not create a new volume. Already Rajesh volume is there, right? I will use Rajesh volume with that container also. So same volume only, I will attach it to one more container. Okay, so 2 containers can use simultaneously. Okay, so let me run Docker space run space Okay, hyphen id. Okay, hyphen name. Let me create a container over here as C7. I'm creating a seventh container, and you have to give some privileges over here, guys. Nothing but you have to give some permissions over here. So I will write privileged over here. Okay, and give privileged equal to true. Okay, and what permissions you want to give over here? You want to give your volume permissions, right? So say hyphen volumes from, so from which container you want to share the volume? From container 6 you want to share the volume, right? And container 7 should get created with Ubuntu image. So you will write Ubuntu over here, and you will write bash to go inside container 7. Okay, so what you are doing over here is you are giving some privileges. I'm giving some permissions over here. I'm giving permissions to C7 container so that it can use the volumes from C6 container. And C7 container should get created with Ubuntu image, and I'm going inside this container using bash. Okay, so I'm giving my privileges, nothing but permissions to C7 container so that it can use volume from C6 container, guys. Okay, so I'm giving some permissions. I'm not creating any new volume. I'm already sharing my volume from C6 container. Okay, so now if I give enter over here, you can see the container got created, and I'm inside my container also, right? And if you give ls over here and check, Rajesh volume should be there. Okay, and you see that Rajesh volume is over here. I did not created Rajesh volume again. It is already there with C6 container. Now I have attached this with my C7 container, and you can see Rajesh is available on my C7 container also. So now if I go inside Rajesh, and if you give ls over here and if you check, you can see the same 4 files. You can see the same 4 files which you have created on C6 container. So C6 containers you can view from C7 container also. So same volume we are utilizing with multiple containers over here. So multiple containers can use the same volume also. Okay, so no problem with that, right? Very good. Okay, so now let me give exit over here, and let me come back. Okay, and let me show you one more important thing over here. Okay, so I have these many images. Very good. Now if you want to check what activities you did on that container, so this will be helpful in real time also over here actually. If you want to know what activities you did on that container, which is nothing but logs. If you want to check the logs of your container, you can run docker space log space. For example, I want to check C6 logs, container 6 logs, you will write C6 over here. So logs will give you the logs of your containers. It will show you the activity which you have performed on that containers over here. Okay, so now if I give enter over here, you will see that it will show you the activities which you have performed on this container. So what I did in C6 container is I went inside the container, I did an ls, and then I went inside Rajesh volume, and inside Rajesh volume I did ls, and then I have created files also inside Rajesh volume, and then again I did ls, and then I gave a exit over. So whatever activities you have performed on that container, it will show you in Docker logs over here, guys. So Docker logs will preserve the history for you. It will show the activities which you did on your previous container. So with the help of Docker logs, you will come to know that what are the activities you have performed on that container over here, guys. Right? Now, if you want to check the logs of other containers also, you can give docker space log space container 7. Let me check, and if you give enter in container 7, I did not created any files, right? I just give ls. I went inside Rajesh. Again, I gave ls. That's it. I did not created any command. So it will preserve the history, and it will show me that whatever activities you did on the container, you can show. Okay, so be very careful in real time, because as I told you, it's a very smart tool. It will record your activities which you are doing over here, so that your team lead and manager will come and check that what activities you performed on that container. They'll simply give Docker logs and they will come to know that what are the activities you performed on that container over here. Right? So it will show you the entire activities over here that which we are performing over here, guys. Right? Now, so let me come back and let me show you one more important thing. So if I give Docker ps-a, so these are the containers which we have created. Right? Now let me delete the container also. Guys. So when we are creating the containers, we have to delete the containers also. Right? And with Docker space rm space, which means remove, you can give container name or you can give container ID also. So Docker remove C1 will remove my container 1 over here. And one more thing, it is telling you one message over here actually that it is a running container. So Docker is a very intelligent tool, guys. It tells you that it's a running container. Are you sure you want to delete it? Because if you delete running containers, it will impact your application. It will impact your main processing application over here. Okay, so that's why Docker is warning you over here that before deleting the container, we have to stop the container over here. See, stop the container before attempting removal. Okay, so what I will do is I will say Docker space stop space C1. So this is the best practice, guys. Actually, you have to first stop the container and then you have to remove the container. So I'll say Docker stop C1 and you will see that C1 got stopped over here, right? So now I can run Docker space rm space C1 and if you give enter, it will be removed. Now C1 container got removed from our container list. Okay, so if you check Docker PS also, okay, it will not show you any C1 over here. See C2. From C2 it is showing, right? Now, okay, if you want to delete images, so for removing containers, you are using Docker rm command, and for removing images, you will use Docker space rmi command, guys. So rmi stands for remove image, and simply for removing containers, you will write rm only. So rm for remove containers, rmi for removing images. Okay, and let me write the image over here. For example, I want to delete MySQL image. Okay, and let me give enter over here. So it will remove my MySQL image over here, guys. Okay, so I'll give enter over here and you see that MySQL image got removed from over here. Okay, so you have to remove the images which are not being used by your containers. If your container is already running with some image associated to it, cannot remove. I deleted MySQL container, so I'm removing MySQL image. Okay, so now if you check images over here, MySQL image should get deleted from over here. See, MySQL image is not there. Okay, so you can remove your containers, we can remove our images, you can delete your containers. Okay, you can delete your images as well over here, right? So anyhow, okay, so these are the list of commands, okay, which we have performed over here. So anyhow, it was a recording, right? So you can go through these commands and do your, okay, practice with a good hands-on with all these commands. Okay, so going forward, what I will do is in my next session, I will create my own images, guys. Right now we are using images which are given to me from Docker Hub. Anyhow, these are official images only, verified and official images. They are verified and they are official. It will be very good to use. Okay, no problem with that. But I will create my own images, guys. So in real time, what will happen according to your requirement, according to your application requirement, according to our company's requirement, we have to create our own images. So Docker gives you the option to have your own image. You can generate your own image also. So for that, we have to write one script. Okay, we have to write one script and we have to create our own images. Okay, so in our next session, we will write our own script and we will create our own images from that script. Okay, oh, which is Docker. Docker has its own syntax. Okay, it's not like Java programming or Python programming. It will be simple only, simple instructions. It's a Docker script only. Okay, not complex, simple instructions. That is the advantage. That is why it is different from programming. Okay, so we will use that instructions and we will create our own images over here, right? So you guys, okay, just have a good practice with all these commands that which you have performed. You will get more and more comfortable onto the container side, and we will be going forward with more advanced things to be added over here, right? So let me just save the share for our